Good morning, everyone. Welcome back. So far in Module 1, we have explored the philosophical origins of artificial intelligence, symbolic AI, and the rise of rule-based intelligence systems. Now, in this session, we move into something extremely important in the history of enterprise technology, expert systems. And honestly, this was one of the first moments when organizations truly believed intelligent machines could transform business operations. Now let us begin with a simple question. What exactly is an expert system? At a basic level, an expert system is a computer system designed to simulate the decision-making ability of a human expert. Now think about that carefully. Not general intelligence, not autonomous reasoning, specific domain expertise. For example, medical diagnosis, financial risk analysis, manufacturing quality control, legal compliance, tax assessment, industrial troubleshooting. The goal was simple: capture expert knowledge, convert it into machine-readable rules, and allow machines to generate decisions consistently. Now, from an enterprise perspective, this sounded revolutionary because organizations constantly depend on specialized human expertise, and expertise is expensive. Expertise is difficult to scale. Expertise creates operational bottlenecks. So enterprises became very interested in systems that could preserve and automate expert-level decision-making. Now here is how these systems typically worked. Human experts contributed knowledge. That knowledge became rules. Those rules were stored inside something called a knowledge base. Then an inference engine processed those rules to generate conclusions. Very important architecture. Knowledge base, inference engine. Decision output. This became one of the earliest operational AI architectures inside enterprises. Now let me give you a practical example. Suppose a manufacturing system detects abnormal vibration inside industrial equipment. The system checks predefined rules. If vibration exceeds threshold and temperature rises and rotational imbalance is detected, possible bearing failure, maintenance alert generated. Now today, this may look simple, but historically, this was extremely powerful because machines were now assisting operational decision-making at scale. And enterprises love this. Why? Because deterministic systems create predictability. The same input produces the same output every single time. That creates operational trust. Now, this is a very important phrase. Operational trust. Enterprises do not adopt systems simply because they are intelligent. They adopt systems because they are reliable, predictable, auditable, and controllable. And expert systems delivered exactly that. Now, during the 1980s, expert systems exploded across industries: banking, healthcare, telecommunications, manufacturing, defense, insurance, government systems. Organizations invested heavily in deterministic AI architectures. And for a period of time, many researchers believed expert systems represented the future of artificial intelligence. But underneath this success, serious limitations were emerging. Now, this is where things become architecturally interesting. Expert systems were powerful in stable environments. But the real world is not stable. Business conditions change, customer behavior changes, language evolves, regulations evolve, market dynamics evolve, and every time reality changed, humans had to manually update the rules. Now imagine maintaining thousands of rules across massive enterprise systems. The operational complexity became enormous, and another major problem appeared. Expert knowledge itself is difficult to capture. Human experts often make decisions using intuition, experience, context, and incomplete information. But deterministic systems struggle with ambiguity. They struggle with uncertainty. They struggle with dynamic context. And eventually, organizations realize something important. Human intelligence is not merely rule execution. True intelligence requires adaptation, and adaptation requires learning. Now, this realization changed the direction of AI permanently because enterprises no longer wanted systems that only followed predefined rules. They wanted systems capable of learning from data, learning from patterns, learning from behavior, learning from experience. And this transition became one of the most important shifts in AI history. We moved from knowledge engineering to machine learning, and that transition transformed modern artificial intelligence forever. Now, before we close, I want you to remember one critical insight from this session. Many enterprise systems today still operate like advanced expert systems. Workflow automation, compliance systems, business rules engines, approval systems, decision trees. Even modern enterprise software often contains deterministic reasoning layers underneath. So, understanding expert systems is not just historical knowledge, it is operational knowledge. Because the DNA of early AI systems still exists inside modern enterprise architectures today. And understanding those foundations helps us understand why modern AI evolved toward adaptive intelligence systems. Thank you, everyone. And I will see you in the next session.